Hello everyone. So we are back with the second lecture of the series on Vedic mathematics. Yesterday we discussed about the third unit of our curriculum, that is lightning squares and rapid cubes. Let's start with the same lecture. Yesterday we discussed about the case 1 of Yavadunam Taradhuni Kriti Vargena Yojayat Sutra, which is used to find the squares of numbers near to the base 10 to the power n or of the multiples of 10. So yesterday the case first was of the multiples of 10 to the power n, or we can see. Today we are discussing about case 2 when the base is not in the form of 10 to the power n but a multiple of 10. For example, if a number, let's take an example, if a number lies close to the base 20. So 20 is not in the form of 10 to the power n, but instead it is a multiple of 10. Or we have any number close to number 30 or 40 or 200, 300, 500, 5000 and so on. So what to do with those numbers which lie close to these bases which are a multiple of 10? This is actually the second case of Yavadunam Taraduni Kriti Vargena Yojayat. In this case, we can take the LHS of the separator equals to number plus deviation into sub-base. We will discuss it into the examples, how to form the sub-base, what is actually an actual base and a working base, and the right hand side of the separator equals to square of deviation. So to make it more specific or more particular, let's move on to the example. So here is the example first. Find the square of 32. So 32 students, if we take, this is close to the number 30. We can solve it by using that it lies close to the base 10 to the power n as well. But here, if we take 32 number, it lies close to the number 30. So 30 in this case is the working base. Remember, once again, I am repeating, 30 here in this case is the working base. So 30, we have to first determine that it does not lie close to any actual base. So we have to look for a working base, which in this case is 30. After setting the working base, which is 30, because 32, again 32 lies close to the base. 32 lies close to the base 30. So after setting the working base, which is 30 in this case, we will look for the deviation. The given number is 32. And the working base now is 30. So 32 minus 30 equals to 2, which is the deviation. I have mentioned clearly over here that 2 is the deviation in this case. Now 30 can be written as 3 into 10. That is, 30 is a multiple of 10. Here you can see clearly on our screen that 30 can be written as 3 into 10. That means in this case, 3 is the sub base and 10 is the actual base. Now there are 3 important points here you need to remember about. If we have to find the square of 32, then first we have to set the working base, that is 30, because 32 lies close to a multiple of 10, which is 30. After we set the number 30, that is called as working base, we have to get 30 as a multiple of 3 and 10. So 3 in this case is sub base and 10 is actual base. Now let's find the square of 32. 32 square equals to 32 plus 2, which is deviation, into sub base, which is 3, separator 2 square. This separator here, students, this separator, this is called the left hand side, as we have discussed in the previous case. LHS of the separator equals to number plus deviation into sub base. So here you can see 32, which is the number, plus 2, which is the deviation, into 3, which is the sub base, and slash 2 square. In the previous case, you can see RHS of the separator equals to square of the deviation. So this way, 32 plus 2 is 34, into 3 is 102, and 2 square is 4, that is 1024 is the square of 32. So again, I'm repeating things. When we have to find the square of any number that doesn't lie close to a base, in the form of 10 to the power n. In that case, we have second case for YKTVY, which is that we have to find a base, a working base, which is a multiple of 10. Here, when we discuss about finding the square of 32, it lies close to a working base, which is 30, and 30 clearly is a multiple of 10. So 30 is the working base. 30 can be split into 3 into 10. So 3 is the sub base and 10 is the actual base. So when we come to find the square of 32, that is 32 square equals to given number plus deviation into sub base slash deviation square. In this way, you can find the square of any number which is a multiple of 10. Let's move to the second example. Yeah. If you have to find, there is another number, if you have to find the square of 47. So 47 again lies close to the base 50, which is a working base. So here in this case, if you see 47 lies close to the working base 50. So second thing, step 2 or second thing is to set deviation. So 47 lies close to the working base 50. So the deviation in this case is negative, which is -3. In the previous example, if you see, the deviation is positive 2 because the number is greater than the base. And here in this case, you can see the number is smaller than the working base. So the deviation is negative. Deviation, as we have already discussed in our previous lecture, can either be positive or it can be negative. So now 50 can be written as we did in the previous case. 50 can be put as 50 equals to 5 into 10. So you should be well aware of now that 5 is the sub base and 10 is the actual base. So to find the square of 47, we have the formula given as 47, which is given number, plus minus deviation. Plus deviation is the formula, but here you can see we have deviation as negative, that is plus minus equals to minus, that is 47 minus 3 into sub base, which is 5 in this case, slash -3 square, which is deviation square, that is 9. So 47 minus 3 is 44 into 5 is 220, and 3 minus 3 square is 9, that is 2209, which is the square of the number 47. Remember one thing, students, here we have the formula as given number plus deviation into sub base separator deviation square. But here, as the deviation is negative, so we can say 47 plus minus 3, that is 47 minus 3, that is why minus is given there. Instead, it is a plus sign. So this way we can find the square of any number which doesn't lie close to the base, but instead is a multiple of 10. So in the previous case, we can see the deviation was positive, that is 2, and in this case the deviation is negative, that is -3. Let's take one more example, that is find the square of 482. Here in the previous two examples, we have taken 2-digit numbers. Now here we have a 3-digit number because this method can be used to find the square of any number. So let's take the example of a 3-digit number, which is 482. When we need to find the square of 482, again we need to look for its actual base. If the number doesn't lie close to any actual base, so we have to look for a working base, which here in this case is 500. So if you see at the number, if you look at the number 482, students may get confused sometimes that whether to take it close to the base 100 or close to the base 1000. So this is for those problems, this case 2 is discussed for those problems in which there is an ambiguity among students to decide whether the given number should be taken close to the base 100 or close to the base 1000 or closer to the base 1000 or closer to the base 10,000. For example, if we take the example of 5639, which is a 4-digit number, sometimes students may get confused whether to take it close to the base 1000 or close to the base 10,000. So for those cases, we are discussing case 2. So here you can see that 482 is a number which is in between, almost in between the base 100 as well as the base 1000. So students sometimes may get confused, and in this process it can take a lot of time. So as Vedic mathematics deals with the calculations to make them easier and very fast, so this case is discussed for those scenarios. Here you can again see that we are setting a working base which is 500, as 500 is a multiple of 10. So 482 lies close to the working base 500. So remember once again, 500 here is a working base. So deviation of given number from working base is 482 minus 500. So the deviation is minus 18 because the number is smaller than the working base. So deviation again is negative. Now we can see that 500 can be put as 5 into 100. And remember here, this is a 3-digit number. So the base is 100, actual base is 100. So 500 can be put as 5 into 100, which means that 5 is the sub base and 100 is the actual base. 500 is the working base. Now to find the square of 482, that is given number, which is 482 minus 18. Again, I am saying that it is plus deviation, but here as the deviation is negative, so 482 minus 18 into sub base, which is 5 in this case, and separator, to the right of the separator is deviation square, which is minus 18 square. So when we subtract 482 minus 18, that is 464 into 5, and this is minus 18 square is 324. Now you see 464 into 5 is 2320, okay, and this is 324. We have already discussed in our previous lecture that if the base contains 2 zeros, which in this case is 100 containing 2 zeros, that means to the right of the separator there should be a 2-digit number instead of 3-digit number. So what we do in that case is we move this 1 digit to the left and add it to the given number. So we have already mentioned here in this box, as the base have 2 zeros only, so only 2-digit numbers allowed on the right hand side. So this 3 will get added to 0, 2320, the given number. So that becomes 2320 plus 3, which is 2323, and separator 24. Now we are okay, we have a 2-digit number to the right of the separator, so this becomes 232324, which is the square of the given number, which is 482. So this was example 3. Another example is find the square of 612, which is again a 3-digit number. So we will proceed with the same procedure, or we will follow the same procedure. To find the square of 612, we need to look for an actual base, and if it is not lying close to any actual base, we will look for an working base and then set the sub base and then find the square of the number using Vedic mathematical techniques. So here, if you see, students may get confused sometimes that whether 612 lies close to the base 1000 or it lies close to the base 100. So for this case, we will look for a working base instead of looking for an actual base. So when we look for a working base, here in this case, 612 lies close to the working base 600, which is a multiple of 10. You should always remember that the working base should be a multiple of 10, which is the foundation of this case too, using the Avadunam Taraduni Kriti Vargena Yojayat. So again, it lies close to the base 600, so we have to set the deviation 612 minus 600, that is 12. So deviation in this case is positive. So after 600 can be put as 6 into 100. 6 is the sub base, 100 is the actual base. So we will look forward for finding the square. So 612 square equals to given number, which is 612, plus deviation, which is 12, into 6, which is a sub base, and separator to deviation square, which is 12 square, that is 144. This is 3744 after getting the multiplication or simplifying it simply, and then we have 12 square is 144. Again, to the right of the separator or the right hand side contains 3-digit number. It's a 3-digit number, but the base contains only 2 zeros. So in this case, again, we have to move that 1 digit to the left of the number and add it to the left number. So we will add this 1 to 3744, which becomes 3745, and then we are left with only 2-digit number, which is okay because the base contains 2 zeros here. So this becomes 374544. So this is the easiest way. Using Vedic mathematical techniques, we can find the square of any number using these two cases. Again, repeating, the first case is when the number lies close to the base 10 to the power n, and when it doesn't lie close to any number in the form of 10 to the power n. In that case, we can take a working base, which is a multiple of 10. So we have discussed both the cases, and we have discussed some examples on these. So I have given some examples for students to try these examples at home. That is 95 square, 302 square, 89 square. You can try these examples using these two cases, and you can come up with your results. Okay, these are a few examples that you need to try at home. So let's move forward to another sutra or another formula for finding the squares of number using Vedic mathematical techniques. That is Ekadikena Purvena Sutra. So this sutra is used to find the squares of numbers that end with 5. For example, if you have to find the square of 65, 45, 55, 75, 175, 285, so those numbers which end with 5, you can use this sutra to find their squares. So square of, in other words, we can say that Ekadikena Purvena Sutra means square of numbers ending in 5. So the sutra used to find the square of these numbers is by 1 more than the previous one. So we will clarify it, or we will make it understand to the students by using an example. So example 1 is find the square of 75. Here you can clearly see that the number is a 2-digit number and it is ending with number 5 or digit 5. So to find the square of these numbers which end with 5, Ekadikena Purvena Sutra, or we can say that square of numbers ending in 5, we simply multiply the first number, which is 7 in this case, by the next number, that is 8. So 7 into 8 equals to 56, which is the first part of the solution, and the second part is the square of the second number. So let's clarify it. If we have to find the square of 75, so 75 square means the given first number is 7. So we have to multiply it by 1 more, by 1 greater than it. That is 7 plus 1. So 8 is greater than 7. Then we have the separator. Then we have the second number square, which is 5. So when we multiply 7 into 8, that is 56, and separator, we can use 5 ka square, that is 25. So this is 5625. In this way, we can find the square of any number ending in 5 using Ekadikena Purvena Sutra. Again, if you have to find the square of any number, which in this case, example first is 75, you take the multiple of 7 with the number that is following it, immediately following it, which is 8 in this case. So 7 into 8 is 56. Then the second number, we have to take the square of that number and put it on the right hand side. So here we have again the left hand side as well as the right hand side. The left hand side contains the given number plus into the number just following the number, which is 8 in this case. Then we have separator, and then we have the square of the second number, which is 5 square equals to 25. And in this way, we can find the square of 75, which is 5625. Let's take one more example based on that. So this is a 3-digit number. In previous example, we have discussed about a 2-digit number. So 3-digit number here again, ending with 5. So we can use again this Ekadikena Purvena Sutra, or you can use the previous ones to find the squares of these numbers. But For numbers ending with 5, we have one more extra method, or you can use this Ikadikena Purvena Sutra. So 605 is again a number ending with 5. To find its square, we have just split it into two parts. The first part is 60 and the second part is 5. So first part is 60 and second part is 5. Now, as per formula, as per Ikadikena Purvena Sutra, 60 is to be multiplied by the number immediately following it, that is 60 plus 1, and then we have separator, and then we can use the square of the second number. So by this Ikadikena Purvena Sutra, students should not feel confused, or they should not get confused. The simple formula is, or the simple sutra is, if you have to find the square of any number ending with 5, you just take the given number. The first number is 60, then you take the multiple of the number immediately following it, that is 60 plus 1, or we can say 61. So that is immediately following 60. Then we have the right hand side part of the solution, that is the second number, which is 5, and 5 square, we have to take the square of that number, that is 5 square. So this is 60 into 61, then we have 5 square, which is 25. 60 into 61 is 3660, and slash separator, or we can say in other words, is 25. So that is, then we remove the separator, that is 3660, 25 is the square of the number 605, which is a three-digit number. Let's move to one more example to make it more clear to the students. And this time we have taken the example 3, which is a fractional number, or we can say that it is a number 7.5. So how to find the square of this type of number, which is given in the form of a fraction? So again, this number is ending with 5. So we can simply use Ikadikena Purvena Sutra. So by Ikadikena Purvena Sutra, this number can be fabricated or split into 7 and 5. So the left hand side is 7 and the right hand side is 0.5. Now use Ikadikena Sutra again. The number is 7, then we have to multiply it to the number immediately following it. We can write 8 or 7 plus 1 in this case. Then we have 0.5. The right hand side, we have to take the square of that number. That is 7 into 8 is 56, and 0.5 square is 0.25. Again, which is 56, and this is 0.25. If we remove the separator, if we combine the number, that is 56.25, which is the square of the number 7.5. So this way you can use Ikadikena Purvena Sutra to find the square of any number ending in 5. Remember here, you can use the previous techniques as well to find the square of these numbers, but this is an extra sutra, or we can say an additional sutra, to find the square of numbers ending in 5, which is a particular case, we can say, or which is a special case. So for numbers ending in 5, you can use this Ikadikena Sutra. Otherwise, you can use the previous two sutras or the previous two cases, YTKVY Sutra, to find the square of these numbers as well. So here we have given some examples to find which are the numbers ending in 5. So you can use these techniques, Ikadikena Sutra or Ikadikena Purvena Sutra, to find the squares of all these examples. The first one is to find the square of 95. Again, it is a number ending in 5, so you can use Ikadikena Sutra. And in the next 10-12 examples, you can use this sutra to find the square of these numbers. So today we have discussed the case 2 of YTKVY, that is Yavadunam Taraduni Kriti Vargena Yojayat, and the second one is we have discussed about Ikadikena Purvena Sutra to find the square of those numbers which end with 5. In the next lecture, we will discuss about more methods to find the squares of numbers, and we will discuss about the methods to find the cube roots of numbers. This will end the unit 3rd of our curriculum, and let's move to the next lecture. Thank you very much.